Let's start the day off with a glass of coffee. This is a good cup of coffee. I wonder, how do they make these? Let's go find out. Shall we? The internet said that the coffee powder was made by chemical engineers. So chemical engineering is a certain type of engineering which deals with the study of operation and design of chemical plants as well as methods of improving production. The process that they used to obtain the coffee powder was through leaching. I think I'll have to ask my chemical engineering friend Souleymane to explain more of the process.
Separation is a process of mass transfer that converts a substance in a mixture into a distinctive product mixture, or in some cases separation is used to divide mixture into its pure components.
Types of separation processes. Evaporation. This refers to the evaporation of a volatile solvent such as water from a non-volatile solute such as salt or any other material in solution. Drying. In this operation, volatile liquids, usually water, are removed from solid materials. Distillation. This is an operation whereby components of a liquid mixture are separated by boiling because of their differences in vapor pressure. Absorption. In this process, a component is removed from a gas stream by treatment with a liquid. Liquid-liquid extraction. In this case, a solute in a liquid solution is removed by contacting with another liquid solvent that is relatively immiscible with the solution. Solid-liquid extraction, also known as leaching. This process involves treating a finely divided solid with a liquid that dissolves out and removes a solute contained in the solid.
Hi guys, for my part I'll be explaining the concept of solid-liquid extraction. Solid-liquid extraction can also be called leaching. Solid liquid extraction is actually one type of separation process that chemical engineers use in the industry. The concept of solid liquid extraction is actually pretty easy. As its name suggests, solid liquid extraction is actually a process of removal of a solid component from a solid by using a liquid solvent. The simplest daily life example that I can tell you guys is when we are making coffee. Hot water actually acts as a liquid solvent to extract the solute component from the coffee, where the coffee bean actually acts as a solid substance. Also, as you can see, from the small scale process, chemical engineers just scale it up bigger to produce a bigger output to meet up with the demand of the industry. Lastly, there are three other types of extraction, which are solid extraction, hot water extraction, and ultrasonication technique. That's all.
So for the next part, I'm going to lay out the general step of a solid liquid extraction. The extraction consists of three simple steps in general: combine, filter, and recover. Firstly, we combine the solid with the solvent. Before we mix them, make sure the solvent is in compatibility in terms of solubility with the solid. With this, agitation would occur where the solid would clump together, which leads us to the next step, which are filtration. We filter the solution that has been mixed well to obtain our desired solution, or you can describe the process as extraction. Lastly, we recover the solvent from the moist solid through pressing and drying to get a dry cake of the solid and also the solvent. So now we know how does an extraction process works generally. Are we ready now to perform one ourselves? Nope, not yet, because we need to know what are the factors that could affect our extraction efficiency first. There are mainly three factors, which are particle size, temperature, and viscosity of solvent. To make it easy, let's say we want to make our extraction more efficient. A small particle size is more preferable in this case. Why? This will cause a large interfacial area or contact area between our solid and the solvent. Smaller particle size can be obtained by various methods. The finer the size of the particle, the better, as long as it's not in large pieces. Moving on, we want to make sure the temperature of our solvent is high. Have you ever noticed how you use hot water when you are making coffee in the morning? It is because it allows our material to dissolve better in the solvent. Additionally, it promotes the agitation of our solvent, which what we are seeking for when we undergo the material extraction process. And then lastly, we look at the last factor, which is the viscosity of solvent. Of course, we want to utilize every surface area that is being offered by our solid, right? When the solid have large interfacial area, we want our solvent to be in contact with the solid thoroughly. Thus, the flexibility of the solvent is important, which means a lower viscosity of solvent is preferable to make our process more efficient.
So now we know how does an extraction process works.
Thanks, Ariff. Let me take it from here. Oh, looks like we're out of coffee. First, let me take you guys to my favorite cafe. So today I'm going to show you real-world applications of solid liquid extraction. One of the most widely used solid liquid extraction systems is the espresso machine. First, the coffee beans are made into fine grounds for more contact area with water. They are then tamped into the filter to add resistance to the water flow, increasing pressure and extraction time. The filter is then engaged and sealed into the machine. After the machine is activated, it injects a stream of hot water at approximately 9 times the atmosphere into the coffee grounds. The process takes about half a minute to complete the extraction, unlike how my friend made his coffee earlier. This method of extraction is able to increase the efficiency of extraction much higher by controlling the pressure and the contact time, which makes the coffee extract much more concentrated. Now that we're all filled up with coffee, I'm going to take you guys to a factory which uses a large-scale solid liquid extraction. This industrial plant operates leaching of gold by using cyanide solution. After the gold ore is crushed and milled into the desired size, it is mixed with a solution of sodium cyanide to create a slurry, which contains cyanoaurate ions. This process usually takes 24 to 48 hours before the slurry is filtered and sent to further processing, such as carbon adsorption.